So we'll be solving this problem, which is about single phase half wave control rectifier. So the first thing is to draw its circuit diagram, and then we'll look at its switch equivalence, then we'll fill in this table. And then we'll calculate the average power delivered to the load. Okay, so the circuit for this looks like that you have a supply connected to load, which is a pure resistive load this time, and the value of this is, if you look at the statement, it's 10 ohms, and here is 120 volts for the AC source, and it's connected through an SCR, so it's a control rectifier. So this SCR makes it a control rectifier. Control. Okay, so now what we are looking at is we are looking at its what are the states of SCR to draw the switch equivalence. So the first thing is to look at the state of SCR. So when is the positive half cycle? SCR is for biased. It is for biased, but we are given the SCR and we are given that the delay angle alpha equals to 30 degrees. So till 30 degrees there is no gate signal applies. That means it is in forward blocking state. So what does that mean? It's not conducting, so it's replaced by represented by an open switch. Now at 30 degrees the gate signal is applied, and for the entire half cycle for us to appear, SCR will start conducting. So it is forward biased and it's conducting. And then a conducting SCR could be replaced by a closed switch. Now comes to the negative half when the supply reverses its polarity. So at that time the state of the SCR will be that it's reverse biased, and we know that the reverse biased SCR is an open switch. Now if we use these three states of the SCR and we try to replace the SCR with its equivalent switch. So let's draw the equivalent circuits. The first one is 0 to 30 degrees. So you have the AC source, which is 120 volt, and then you replace the SCR with an open switch, and then you have the resistor in here. And the voltage across the load is VO, the current through the load is IO, and the voltage across the SCR is, let's say, HK or BSCR. Now if you look at this circuit diagram, you can write the values in here. So you can see that it's an open switch. VO is 0, IO will be 0, and if that is the case, this will equals to BS, because this side is connected to the source and this side is at 0 volts. So if you look at this point with respect to this point, the voltage is VS with respect to 0, so it is VS. And then the next circuit is your 30 degrees to 180 degrees, right? So you have a closed switch SCR, which is connecting the supply to the load, right? Again, you mark all the voltages and current in the circuit, whatever we are observing, and this is 120 volt supply. Now for this circuit diagram, if you want to analyze its behavior, so your output voltage equals to a source voltage. I'm good, how are you? And then IO equals to VO over 10 ohms, and here VAK, since it's conducting, so equals to 0. Usually it's 1 to 3 volts, but you can have it as 0 because we are assuming that it's an IQ switch. Okay, the next one is for the negative half of the supply, which is 180 to 360 degrees. So say again an open switch, but the big difference is here in this case the voltage across the SCR is is not positive VS anymore. It's going to be negative because that is what is reverse biasing it. So again, if you write all the variables in here, so here you have 0 and a 0 current, so this equals to negative of VS, and this is your 120 volt supply. So those are the three equivalent circuits, and they gave us the values for all the parameters what we are observing. Now let's go back to the table and fill in their values in the table. So the first 0 to 30 degrees, the SCR is off, and we have the load voltage and load current 0, and the SCR voltage as the positive VS. Then it starts conducting at the firing, and your load voltage equals to the supply voltage, and current is the load voltage divided by the resistance value, and it starts conducting, so this equals to 0. Now during the negative half again, it's off switch, and you have the load voltage and load current 0, and this equals to the negative of the supply. Now we are left with is the calculation for the average power delivered to load. We can use a basic formula for power calculation, any of the formulas for power calculation. The standard formula V times I, V squared by R, or so on, and I squared times I. So let's do this basic formula, which is V squared divided by R. So since we are calculating the average value of the power, we are taking the average value of the resistor. Right, so there is the formula for VO average. It's P.Eng over 2 pi 1 plus cosine of alpha, and then you take a square of that divided by R. Now your Vm is the peak value of the source, which is square root of 2 times 120 volts. Alpha is 30 degrees, so we have to make sure that the calculator is set in degrees, and R is 10 ohms. If you plug in all the values, then your PO average is expected to be 254 watts approximately.